For your help and advice and things over the last few months. Yes, yes, Duncan is my name. Was it? Yeah, there was another question that's completely unrelated to this. It was about grabbing some data from an API and processing it. But as you say, who knows what football has to do with this? That later on they constrained the scores in the match to less than 10 to the 9, I think, which is that's an awful lot of points. So it clearly has nothing at all to do with any real world situation. Why, thank you. Um, COVID and sitting inside is maybe big enough, but sure. Well, you nailed it this time. On the basis that I put together a couple of answers that worked, and actually the first one fairly quickly, I think I got to what they were trying to ask. Well, they're giving you two arrays. For each, sure, that sounds good. Yep. Yeah, you're there, but with, again, yeah, words down in the way. So you're given two lists for each member of the second list. Find the total number of members of the first list that have a lower value than that member of the second list, and then return a list that contains that. Yeah, because they're not having matches against each other, which is how it vaguely makes sense to ask the question like this. They have each played some matches in the league, and those are the points that they scored in their matches, but they're not matches against each other. So roughly, yes, but not the match between A and B, but the match for which you are for which you're comparing the score. So as you're saying, forget the matches, the football, the everything else, and another example makes a little more sense. I don't know what a real use case is. They walk it through there, and there was another. I grab the other example up, so I talk through that as well. So the first member of array B is 2. It's this odd situation where I get the impression that as a junior engineer, you're kind of going to be given a pretty well-defined problem to solve. And you're going to go and technically solve that and come back and no doubt be told to improve it. But all of the interview questions contain an awful lot of parsing of real world situations and translating into what it is they want to help the other side. Those two, it seems like there's a big gap between what the interview questions are and what you're actually going to be asked to do. You're going to present the count of rather than presenting those themselves. But, yeah. The number of matches. So for each member of list B, return the number of members of list A that have a lower than or equal value to the value you're looking for. Yes. Whilst I agree, I have a couple of small test cases that I know are valid test cases. So perhaps we start there and then extrapolate from them. Okay. Can I suggest in your inputs you have a couple of extra numbers that are between 5 and 9. So add a 6 or a 7. Cool. Yeah, so we get different answers. Mm-hmm. If you guys are scoring 10 to the 9 points, good for you. A lot of touchdowns. Yeah, so that looks like the immediate solution that I threw in before I properly read the size of the constraint and realized that there was any sort of time consideration. Yeah, for 100,000 inputs or 10,000 on each side, it takes 70 seconds to resolve on my reasonably competent computer, which is, yeah. So what are you expecting your outputs to be from your test case there? Yeah, I'd agree. Yeah, I'd agree with that. One of us can't do maths. Yes. It might still be the wrong way around. Yeah, that's right. Mm-hmm. Those keyboard designers who didn't think about coding back in the day when they stuck those next to each other. Yeah. Actually, you've got up to 10 to the 6 inputs in each array. Yeah, I'm not sure if that's 100 million or 10 million was the... Oh, you're right. Okay, so I was probably going too far doing my solution for 10 million. But once you're efficient, yeah, 10 to the 9. A minus B, ascending order. Unless I did mine all wrong, which is possible, but I'm pretty sure. Yeah, I'm pretty sure it's ascending order because I did it the other way around first. Mm-hmm. Yeah. Uh, Even if there are some collisions, that's not going to be material to the scale of the problem. There were there were no memory constraints. What matters is you get out the other side in the correct order. Hmm.
Oh,
You want to
dang
start the
it.
problem again?
Oh, no. The alarm said Duncan's voice can be heard, and that's all I saw. I thought, oh, good, Duncan's voice can be heard. What he didn't tell me was AJ's voice can't be. Well, he did say this, I just didn't see it. I couldn't hear me. Okay, oops. Well,
We're going to give
we're not going to go
a
back
two
to the
minute
top.
summary then.
I'll give a 2 minute summary. Okay, so, hey, Josh, will you edit this part or something? I guess timestamp link into this. Yeah. Ugh. Okay, so I couldn't be heard. I'll take it from the top. We'll do the 2-minute summary. Hey, yo. Welcome back, everybody. Got some Mountain Dew Baja Blast. And I've been working through a problem here with Duncan, an interview problem. And apparently my mic wasn't on because I did the meetup on Thursday and I didn't stream last night. And every time I disconnect and reconnect things, of course, the mic and all that, it can't remember which one was selected when I plug it back in at home. And anyway, so we've got this really obtuse interview problem, which I hate these because to me, it feels that they're designed to be misleading because it says football scores. This has nothing to do with football. There is nothing about this problem. So I just wish that they would have said, comparing lesser sets of numbers. Like that would make more sense to me rather than them trying to say, oh, this is football. It has nothing to do with football. You don't score between 1,000,000 and 1,000,000,000 points or between 0 and 1,000,000,000 points for 0 to 1,000,000 football matches. That's just not something you do. And you don't compare values of team A and B that have nothing to do with each other. But anyway, we were trying to figure out what it was that this question was asking. Duncan already knew because he'd gone through it, but I'll just read it out. I stumble on this because I am a native English speaker and I expect words to be correct if you're giving me a problem. If you give me incorrect words that mean the wrong thing, it's going to trip me up. I'm a very literal thinker, so I hate these problems. So the number of goals achieved by two football teams in matches in a league is given in the form of two lists. So saying there's two lists of random numbers is what it's saying. Between 0 and 1,000,000. No, between 0 and 1,000,000,000. For each match of there's more than what's on the screen here. That's where I pulled that from. For each match of Team B, so this is a lie right here because it has nothing to do with each match of Team B, really. For each match of Team B, compute the total number of matches of Team A where Team A has scored less than or equal to the number of goals scored by Team B in that match. So there's no correlation between the matches of Team A and Team B. They're completely separate matches. So this is just confusing out of the gate because it's talking about these matches as if Team A and B are having matches, but they're not. But the key thing is that the reference, I'm going to call Team B the reference list. So the reference list, you get a reference list with a bunch of numbers in it that are just random between 0 and 1,000,000,000. And you have another list that is inputs. And the inputs are also numbers between 0 and 1,000,000,000. And each of these lists can be between 0 and 1,000,000 long. That was in a part that's not here. And you're trying to output a list that will be the same length as the reference list. But for each number in the reference list, you want to find out how many numbers in the input list are less than that number. So if I give you the number, if the first number in the reference list is 2, like it says here, then I want to go through the input list and count the numbers that are less than or equal to 2. So if I iterate through this list, there's a number less than or equal to 2. There's a number less than or equal to 2. This number is not less than or equal to 2. So my count is 2. And the thing that was confusing about this is all of the numbers that they were giving are actually within the list. So if they had given the numbers 100, 200, 300, and then 200 and 400, and then the output was 2 and 3, that would be a lot easier to understand. But instead, 2 and 2 are both in this list, and 3 is in this list. And so it looks as though this is an aggregate, and this is, it's just completely confusing language. So it really, I would not pass this interview personally, because the interviewers generally don't understand the question either, because they're the first level people and they don't know. So anyway, but what I guess I'll read the rest of this just for completeness. Team A has played 3 matches and scored one goal in the first, 2 goals in the second, 3 goals in the third, and so respectively. Team B has played 2 matches, but this is, again, forget teams and matches. This has nothing to do with teams or matches. This is completely it's just to confuse you and give you bad context so that I don't know. I don't know what the purpose I don't know what they're trying to screen for when they literally give you a bad problems, but I've failed interview questions like this. You can tell I'm emotional about this. Anyway. So let me reread that. So the input list has 3 values, 1, 2, and 3, and the reference list has 2 values, 2 and 4. So for the
first value of the reference list.
Yeah, so for the first value of the reference list, it's 2, and for the first value of the input list, 2, there are 2 values in the reference list. There are 2 values in the input list that are greater than or less than that value, and that's how it gets to that. So the naive implementation, let me just put this in my cut buffer real quick. The naive implementation was that we run this, we say for each reference value, because our output size is always going to be the same as our reference list size. So for everything in our reference list, what we're doing the comparison against, that's why I call it ref, as in reference. For each value in the reference list, where we want to go through each of the inputs from beginning to end and find out which of the inputs are less than or equal to the reference value. So we have I here, meaning our ticker for our reference value list. So this is value 0, this is value 1. And then we're going to go through all the values of the inputs list. And then what we're going to do is increment the number of numbers. We're not adding the numbers, we're incrementing the number of numbers that are less than or equal to the reference value. So for our outputs here, we would be getting 4 and 6, because if we look at numbers that are less than or equal to 5, there's 1, 2, 3, 4. That's our 4. And if we look at numbers that are less than or equal to 100, we've got 1, 2, 3, 4, 5, 6. So that's the recap on this. Okay, so anytime you can't hear me, feel free to just yell louder, because eventually I will look over. Yes, I've joined in. Okay, so this is where we're at, and my thought is that to solve this problem, what they're actually doing is they're presenting a binary search problem. They're just obscuring it quite a bit. There is no way that we can group the values, because the inputs, there are up to 1 million inputs, up to 1 million reference values, and the number of values is 1 billion, which means that there are 1,000 times more values than there are possible inputs, which means that trying to group these together and say, let's count the number of 1s, let's count the number of 2s, let's count the number of 3s, and so forth, is worthless, because only 1 out of 1,000 values will actually be the same. So in our entire list, if we tried to group values that are similar, we would end up only grouping maybe 100 values that have duplicates, or maybe 1,000 values that have duplicates, but we're not going to be doing very many duplicates. And we, the idea that we might have 4 values that are the same is very small. So the problem that what they're trying to get you to do here is they're trying to get you to realize that you need to sort the first list, but the reference list has to stay the same, or at least the outputs have to be in the same order respective to the original reference list. So you need to sort the input list, and that's one pass. So that's ON. Because if you don't sort the inputs list, then you are forced to count one by one by one. If you sort the inputs list, if you were in a language that had functions that could work on sorted lists, which JavaScript does not have such functions, then you could use something like last index of, and it would be able to find the number in the list very quickly. Since we don't have that, we're going to have to do it ourselves. But essentially, we're going to be implementing a binary search where we say, let's pick, I guess let's do len is inputs.length. I'm going to call it M, actually. We're going to do math.floor inputs.length divided by 2. So is that going to work? Or is it length?
That's the typical binary. Yeah.
Well, I got to think if I'm off by 1 on this, because if the length is 30 and we divide by 15, if the length is 0, then this would be wrong. So we need to do length minus 1 divided by 2. Oh, I didn't hit the 1 there. So this is going to be our middle. I'm going to call it mid, or maybe we'll just leave it at M. So then what I need to do is see, oh gosh, let's do V equals inputs M. And then I'm going to check to see while, let's see, V. So this is going to give me whatever the middle value is. So while V is not equal to ref, that might not even be true. I'm going to have to iterate through, and I'm going to have to say, hold on, let me back up. I'm going to have to iterate through it. I'm going to have to say, if this value is on the right, or if this value is less than, then move right. And if the value is greater than, then move left. And if the value is the same, then move right until there is a value that's not the same, which is not likely to happen often, but it is going to be one of those edge cases. All right. So I'm just going to handle this for one value at first and not try to worry about the recursion or the looping or anything like that, because you got to deal with the leaf nodes first. Then you back up and deal with the full array. So even though I'm in a loop, I'm not going to be thinking about the loop. I'm just going to be thinking about this one value. All right, so I want to see if V is less than, let's do this. We're going to do index is equal to M, and the inputs is this whatever V is at that input. So V is less than reference, then that means that we need to move our index over, but we want to move it over not just by 1, we want to move it over by about half. So we're going to go halfway, 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 halfway until we land on the value, and then we'll go by 1 until we end up, let's see. Hold on. Let me think about this.
But it's whilst your target does not equal your reference.
Well, I'm not going to do that yet. I'm just worried about one value. But I'm okay. So if V is less than reference, then what I need to do is I need to move. Well, let's first of all say this. If V is equal to the reference, then I would say get the rightmost value is what I would want out of this. So if V is equal to reference, this is our end case. This is our success case. So let's handle that first. So if V is equal to the reference, then we just want to walk as far right as we can. And we don't have to worry about nulls and stuff because we're in JavaScript, but we would have to worry about this in other languages. So while input plus 1 is equal to V, then I plus equals 1. So hopefully that would never happen. And then we would just want to take, at that point, I think it would be I plus 1 would be, oh, whoops. I'm going to call this refs thing J or K. I'm going to call it K to give myself some space so I can work with I in here and not worry about K until I need it. But I think what we'd say is outputs K is equal to I plus 1. So if it's the 0th element, I is 0, but it means that we have 1.
There's a typo there on outputs.
What's that?
The last T. You're missing the last T on outputs on that line.
Oh, thanks.
Output.
Yeah. All right. So does this, just this part alone, does this make sense? We're basically going to grab an input from the middle. If that happens to be our target, if we happen to hit it on the first try, that, we say we're looking for the number 176. Oh, you know what we need to do? This is tough. Because we're not guaranteed to find our reference value. We have to find something that is 1 greater than our reference value, and then we have to back down to the left.
It doesn't have to be 1 greater, does it?
Okay, well let's play this out. So
random, they could be anywhere.
Right.
Like theoretically, your reference number could be 0 and the first score could be 1,000,000.
Well, let's say that our score values, let's say that we have a value, let's say our reference number, let's make this easy. Let's say our reference number is 200, and our scores, we have a score that's 190 and we have a score that's 210, but we don't have any scores that are 200. That's a case that we have to solve for. So I can't actually check to see if it is. Oh gosh, this is frustrating because I have to find the greatest value that is less than or equal to the reference. So I think binary search is the right way to go about this. But
can you just, if we've sorted our inputs that we're calling them already.
Yeah, the inputs have been sorted.
So if he is, I guess
what's that?
Reverse it depending.
I did not. Would you do that?
Which location?
Chili's.
Which location?
American Fork.
Okay.
Thank you. Okay, sorry.
Thank you for giving up dinner time to come play with this.
Oh no, we're still going to go out to dinner. So this is funny. I didn't have lunch, so I needed to get a quick fix at Taco Bell, but then we're going out to dinner in an hour, a little less than an hour. So hopefully I can get this solved by then.
So much Taco Bell, you can't eat good food instead.
Hey, how quickly are you supposed to solve this problem? How fast was this supposed to be done?
The entire thing was an hour and a quarter for this, plus a fetch from an API and solve. Like I said, so it took me about 15 minutes to read the problem and drop in my naive solution, which obviously failed the long test cases, and then maybe half an hour to do the API search and fetch stuff.
Okay.
Yeah, I couldn't get to, in that time, I couldn't get to a solution to this. It took me another hour and a half, 2 hours afterwards working on this to get the solution that I shared earlier.
Okay.
So can you mark this as a success if V is greater than the reference? You might have to reverse that if you're walking in the other direction.
I'm looking at it the wrong way. So what we need to do is focus on I, not on V or ref. So when we get to the point where I no longer moves, when we get the same I twice, that's when we've arrived at the correct value. So we're going to be moving I either right or left. But when we can't move I right or left any further, that's when we know that we've arrived at the right value. So I got to think about this for a second. How do I... let's see. I'm going to have to keep a ticker of my last I value. This is one where, I hate trying to solve problems under pressure. I would not be able to do this on a timer. My brain would just go insane. Okay, so our last I value. Okay, so we actually have a boundary. I have to think about this. It's been a long time since I've solved a problem like this, but we actually are moving the boundary on the right and left closer and closer, I think. So we're going to start in the middle, and then, so I think we have a left value. I could be wrong about this, which is fine. So let's say that our left value is 0 and our right value is, it would be the length. So it would be inputs.length minus 1. So those are our bounds that we have to operate in. And then we're going to get this value v. And if v, if v is greater than the reference, then we need to move halfway between left and right, and then move our left and right marker, I think. So let me get rid of this other stuff. It's no longer important. So if v is greater than ref, so in this case, say v is 210 and ref is 200, then we're going to have to take the halfway point between whatever, we're moving it to, v is greater than ref, so we need to move I left. So we're going to take our left value and our left value plus our right value, which I guess, let me think about this. Are we starting? It's actually, it's hard to work through this just with you watching and knowing that I'm streaming this. It's more difficult for me to think through the problem. I have severe, maybe not severe, but I have a degree of performance anxiety where when I am in a situation that I'm not comfortable in, I'm not in my zone, and someone is expecting me to do something, I tense up, and it, even in this, I'm the one in control here. I can turn off the camera and go home, but I still have this, my brain locks up a little bit in this scenario. Okay. So
I'm really glad there aren't any whiteboard challenges, tests at the moment. It's all done online, so at least it's not right in front of somebody trying to do it without an editor.
Well, I would actually be more comfortable on the whiteboard, because on the whiteboard, you actually get more leeway. If you screw up on the whiteboard, it's no problem, because on the whiteboard, they just say, oh, well, that's not going to be efficient. How else might you solve this? And you don't actually have to get to the correct working solution where every single test case passes on a whiteboard. You just have to say, this is a binary search problem. Okay, well, how would you go about solving that? And then you start going down this. So I would say it's easier to solve this on a whiteboard than it is to solve it in an online interview, because in an online interview, you're timed, you have to copy over inputs, you have to understand something really obscure. But anyway, so my left value plus, the left value is the base, plus I divided by 2, and then this would be, again, math.floor. So let's call this the J value. Is going to be left. We're moving left, so it needs to be minimum of what our current leftmost value is. Plus, we need to take our I value and divide it by 2. So let's say that our I value right now is at 50. Or let's give it let's say it's at 27. That way we get something that will give us a remainder. So if we take 27 is our index, and we divide that by 2, we're going to get 13.5. So then we're just going to floor that so that we get 13. And then 0 is our left bound. So 0 plus 13 should give us, and I think that our right bound, we know that our right bound we can reduce down to I. We can reduce our right bound down to I because I is not correct. Let me check this. Okay. Couple of messages there. Does that make sense? We can reduce our right bound from inputs.length minus 1 to whatever I is, because we know that we're never going to pass that boundary again. And then whatever our previous left boundary was, which in this case is 0, but it could have been, say, 12. Let's see. Oh, actually, we probably need to do I left. Let's see. I minus left divided by 2 is probably what we need to do. Because let's say our left value were actually at 4. We've decided that our number is greater than 4 somehow. Then we would need to take the current value of I, which is 27. We'd need to subtract our left value from it, which is 4, which would give us 23. We'd need to divide that by 2, which is going to give us 11 and a half, but we're going to floor it down to 11, and then we're going to add our left value to it, 4, which is 15, and that should be half the space between our left boundary and where we just were. And I might have this wrong, because it's probably, if we go one way, we probably need to floor, and if we go the other way, we probably need to seal. But it's a lot of numbers to work with and kind of keep that state in mind. But this J would actually just become our new I, because I've already set I to the new boundary, and then our left doesn't change. Our left is going to stay the same. So I think this would be the result here. And then we would need to continue whatever our loop is. We don't have our loop set up yet, but that's fine. I'm just going to put this here for now. Now, otherwise, if V is less than ref,
I think they're booked out. I cannot call them and I cannot join the wait list.
okay, well then we'll just pick a different place. Do you want to just pick something? Applebee's. She didn't like Applebee's very much. I like Applebee's just fine. All right, so this one, if our value is less than or equal to, let's see, if it's less than, we are still going to run into the case where we need to go as right as we can once we've found a value, because we may have duplicate values. It's not likely, but it's possible. And that's one of the reasons that they made this spread so wide, is that if you're not thinking about it, you'll miss that it's possible to have duplicate values in your naive test. So your tests will pass, but then when you run through their test, it'll fail. But I think this is just, it's kind of a bit much. So we should be doing the exact opposite here. So if our reference value, and no, we did need to change something. Okay, so there was one thing that we needed to do. So I forgot the boundary condition here, but basically if I is equal to J, then this is where to do move right until V not equal V plus 1, or, sorry, we're going to in I is not equal to in I plus 1. So we were going to need to do that in both of these cases. So I guess we would want this to be less than or equal to. Hold on, do we want greater than or equal to? Then we want to move left. Less than or equal to, then we want to move right. I think that's true. I think less than or equal to, we want to move right, and then maybe we wouldn't need this case. I'm not 100% sure. Because if it's greater than, we always need to move left. But if it's equal to, is the only time that we would need to move right after we found the value that we're looking for. So I think this is right. So then let's do bless me. J is equal to right. And I'm going to stick with the floor for now, because that ensures that we don't go out of our bounds. Okay, so I'm going to go back up to this one. I'm going to think through this one for a second. I just want to make sure that my math is right here, that if we, let's say that let's say that left is equal to 2 and right is equal to 3 and I is equal to 3 or an I is equal to 2, then what would happen in
To
this?
walk through the test case that you have set up already.
What do you mean?
Where you have the array of values of the things at the top of this file written in already to walk through that and then step through how the solutions apply to that.
Well, what I wanted to go back to was my calculation of j, to see if my calculation of j is correct, because what we want to see is that when I is at the left or right boundary, that when we calculate j, that j actually will equal to I. And so that's what I realized I wanted to check. So if my left boundary is 2 and my I is equal to 2, then 2 minus 2 is 0, divided by 2 is 0. So then 2 will equal 2, and then we'll find out that I is equal to 2, so that will work. So let's increment I to 3, and let's just make sure, yeah, that should still work. Okay, so I'm pretty sure that math is correct, because here what we would get is 3 minus 2 is 1 divided by 2 would be 0.1, which would round down to 0, which means that left would then go down to, so I would actually end up at the left boundary. So this is slightly suboptimal because we would run I twice for the same value. I could probably compute this slightly differently, but I'm going to leave that alone because it's not going to break. It just might run the loop one more time than it needs to, and I'm okay with that for right now, just to get to the solution. Okay, so then this one is right. So we set our left boundary, we move that up. So let's see, this condition would be that if we're at 190 is less than 200, so we would want to move I to the, hold on. We know that our boundary condition left cannot go any less than what I currently is, so that's correct. And then we want to move I to the right. Oh, and then, whoops, I forgot about this part. We need to say I is equal to j, because we created j so that we have a comparison to check if I didn't move. Because if I didn't move, then we know that we've reached the last possible place that we could reach. And I think I do... We do want to err towards moving to the right, because if we happen to have 2 or 3 values that are the same in a row, we do want to cut them off at the rightmost value. Oh, it's making my brain hurt. This would be a lot easier if we were using a language that had the binary search already implemented in it. But my guess is that if you were using a language like Go, they would be upset and they would want you to use a language where you have to write the binary search by hand.
Python was, I think, what they were after. And I can get it up.
Okay.
I'm glad to see that this is a relatively hard problem to solve.
Yeah, if you practice it. So usually they give you these packets and they have you solve 6 different binary problems. And so if it's been on your brain and you just did one of these yesterday, then writing it again today is not that hard. But if you haven't written a binary search in, the last 4 years, you might remember how to do it, but then actually, I got this edge case I got to worry about. I got this edge case I got to worry about. And just it's tedious.
Have binary search. There's no need for you as an engineer to be writing. But good. So
yeah, most algorithms are
Java,
implemented.
Go, JavaScript, Lua, Python, and Ruby were the
So
options.
all of those except for Java. Well, it depends on how many modules you're allowed to use externally and dependencies and whatnot. But in the standard library of Java, C Sharp, and Go, you're going to have a binary search. It's just part of the standard library. So if the problem is just you're allowed to use the standard. If I was allowed to use Go for this problem, if we were to redo this from the top and I did this in Go, then that would be it right there. I would be doing a sort last index of inputs ref, and that would be my I value. Right, it would be essentially my count would be whatever the last index of is plus 1. So that right there, that's the solution in Go. But if we're actually trying to write it by hand, because there's a sort package and it has the equivalent of a less index of
whatsoever, which is why I had to switch the API request question. I had to switch over to Python because if you don't have any packages and you don't have access to the window in JavaScript, you can't make a fetch.
Yeah, so that Go would be the ideal language to choose for solving these types of problems, because you would get to quote unquote cheat by just using, you could say, yeah, I'm going to select this. I know that I can use the sort function. I know that the sort package does the binary sort for you. No big deal. But yeah, I have never, other than in school, I have never had to manually write, and interviews, I've never had to write a binary search before. So I know how to do it. I know the concept. You're flipping through a phone book. You're trying to find the thing that starts with the letter. This problem is a little bit interesting because you're not actually trying to find the reference value. You're trying to find something that is the reference value or one value to the left. So that's a little bit of a twist that but that's why I would say it's this last index of, because we're trying to find what is the rightmost value that matches this condition. So anyway, so v is less than or equal to, we're moving our left boundary. Yeah, I think we're doing this right. So I think that we actually don't need that. I'm going to break here is what I'm going to do, because I'm going to be slightly inefficient for the sake of simplicity. I'm going to continue here. I'm going to continue here. And then I'm going to do the while loop right here. So let's do while. I'm just going to do while true. Or if I'm going to do that, then I might as well just do for. That's my preferred way to do a while true. It's just a loop. Okay. So input is equal to I. If I is equal to j, break. I is equal to j, continue. All right. And then here, if I is equal to j, break. Otherwise, we also need to move this. That will move it to the right. And then once we've broken out of this loop, then what I would do is say while inputs I is equal to inputs I plus 1, I plus equals 1, and then this number would be what goes in our outputs array. So I guess we would be building our outputs array up from 0. So it's actually just fine if I say, okay, well, there's our outputs array. So I could just take this value here and do outputs dot push and then whatever I is. And I will be our count because it is the index of the sorted numbers. So there's probably bugs in this code, but this is the solution to the problem. So I'll run it. I don't expect it to work correctly. It's probably going to spin.
It's just disconnected, so I can't hear anything anymore.
Oh, let me know when you can hear again, I guess. So I'm gonna try running this. Okay, so I've got a bug because it's just sitting here spinning. So I expected that I'd probably have a bug. So for this, if I is equal, inputs is equal to I. If it's greater than, then we're going to move it to the, so this is move to the left, and this is move to the right. And I think our problem is that here we need to do, I think actually it's the opposite. I think we need to do seal here. And I think we need to do floor here. Because we want to end up at the rightmost value that we can. And that might solve it. Well, no, that shouldn't matter either way. We still should exit the loop. Okay, console.log I. Oops, and V. Let's just see what this says. Okay, undefined. So 8. Let's see, 0, 1, 2, 3, 4, 5, 6, 7. So somehow I got my length off. I'm not really clear on how that happened. So if I is equal to M, oh, maybe this does need to be...
M is the middle.
I'm just going to do this. Let's just log things out real quick. This is actually an interview smell. You shouldn't have to log out your values. You should be able to know what your values are by understanding the code that you wrote. So I'm going to try this just in my brain real quick. So what happened was it was just printing the number 8 out over and over and over again, which was I. So how could that happen? Because it should start at M, which is a fixed value. So let me just console.log M here to make sure that my M is correct. But my M should literally be the middle of my list. Okay, this is, yeah, that's moved to the left. So that should definitely be moved to the right. We want to move all the way to the right that we can. That's seal then. Okay, let me try this again. So M, we have 7 elements on our list. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements on our list, which means that M should be 3, I think is what it should come out to. Because length 7 minus 2. We also could probably do this simpler if we just did inputs divided by 2 minus 1, or yeah, length. This is going to give us the same answer. No, it's not. Nope. Sorry, I was wrong. All right, so we should look at what M is, and then let's just put in here, let max equals, or let count equals 0, count plus equals 1, if count greater than 10, then break. Okay, so V went to undefined. Let's see what our reference value was too. We got a couple of problems here. This was while inputs is equal to inputs plus 1. Okay, so we have 2 problems. This loop is continuing forever because it's getting undefined, and it's just keep on adding. It ends up with the input being undefined, and then it just keeps on adding forever and ever because undefined is always equal to undefined. So that's why we got that.
With the last, doing something else is happening to make both inputs I and inputs I plus 1 equal to undefined.
Yeah.
If it was just moving through the list, then I would have a value. Inputs I would have a value before inputs I plus 1 became undefined.
So I'm going to look at the reference value here, so just so I got a clear picture of this. So the reference value is 5, and
the left-hand side of your terminal is off the screen, by the way.
Oh, whoops! Thanks for that.
That makes a bit more sense now.
Okay. So our middle stayed the same. That's good. Our I value starts, our reference value is 5. And so our middle value is 5, which is good. So we hit the target. So we get less than or equal to right away. And then
Then it walks left. It should be walking right.
yeah. Well, no, this should walk right, but it shouldn't walk right again. So when it sees 6,000, it should try to walk left. And for some reason, it's walking right. So let's logically investigate that and see why that's happening. Let me get.
V should never be equal to 6,000 because you were not checking for V. You were checking for index I versus index I plus 1, weren't you?
But there's two problems. The second problem is that problem, and it will go away when this problem goes away. So if I is at 3, then we're going to get the value 5. 5 is greater than reference? No, that's not true. So it's going to skip this condition. And then I guess this actually could be an if-else, but I prefer to avoid else whenever possible. And that also makes it nicer to leave comments because typically in any if you can either break, continue, or return. And that's typically the best thing to do. Okay, so we have the reference. So 5 is less than or equal to reference. This is true because the reference is 5 and our value is, our value is 5 and our reference is 5 at this point, right? Let me go back up here. Yes. So this is true. So let's do 5. So ref is 5, value is 5. So if that's true, and the index at this point is 3, then we should take our left boundary and make it 3. So we can't go any further left than 3, but we could go further right. So we're going to take our rightmost value. Oh, you know what? I may have swapped these. I may have called the boundaries by the wrong name. I may have mixed up my left and right. Let me think through this again. So we're going to take our rightmost value, which is the very end of this, which is going to be 8, if I'm not mistaken. So we started this. The length is 8, so our rightmost index is actually 7. Okay. So the value here is going to be 7 plus... And then it's going to be, what was it? Was the index was 3 is where we're starting at? Yeah, the index is 3. So we're going to be, in this case, it's right minus I, because now right is the greater value, not I. Okay, so now it's going to be 7 minus 3, which is going to be 4, divided by 2, which is 2. And then it's going to be our... I don't think it's going to be our right value plus this because that would lead us off into no man's land. So I think that it is actually I is going to be our starting point rather than right being our starting point. So I just had those transposed here. So now if we say that it's 3 plus 2, that's going to put us at 5. Well, I don't know what I said there. So yeah, so right is the most it could possibly ever be is 7. Subtracted by where we're at now is 3. That's 4. Divided by 2 is 2. And then we're already at 3. So basically the midpoint between 3 and 7, which, yeah, that's what it did, is going to be 2, which is 5. So then the next one through, instead of landing at... Oh, this is interesting too. I've got... Oh, no, these are when these are sorted, they're in a different order. I need to get that order for myself so that I know what we're working with here. So it's going to be 1, 2, 1, get rid of that, 5. Then it's going to be 16, 79. Wait a minute, we had 3 in there? So 0, 1, 2, 3. All right. I'm just not good at counting in 0 indexed arrays, like most people. And then why is this all freaking out? Oh, it's because it doesn't like that I'm using let instead of var because I don't have a JS hint for this config file. Okay, let me look over here. We still have anybody watching? This is tough stuff here.
You're affecting your nerves. All the people watching you.
Well, there's not that many people watching usually, so it just depends on the day. Friday nights are the best nights to stream if you're targeting watchers. But I do it for myself, and then there's the side benefit of it's cool to build a community in terms of the live stream stuff. I mean, sometimes like this is not when I'm working on things and live streaming it, I'm doing it for myself. Okay, so we still have a problem here. Let's see if it's getting any better. Value. No, it got worse, which I guess is okay. So let me see what happened here. So here right went to I. We clamped down. I'm going to, at the top of this loop, I also want to log out the left and right values to see how they're moving, to make sure they're moving the way that I think they are. Because that doesn't match my expectation. Oh, I did do ceiling where I should still probably be doing floor. That's another problem. In which case, maybe... Okay, this looks a lot better. It's wrong. I think we're still getting bad values. Let's see. Console.log outputs. Let's, oops. Let's see what this ends up with. Okay, we're still getting bad values by a lot. I'm really confused by this. Okay, left is 0, right. So right's not moving to the left. We should have the right moving to the left, especially if I is at 8, which I don't know how it gets there. Oh, okay. I just want to cheat and write this and go now. All right, I'm going to take it from the top one more time.
If that's the interesting part of the problem, is how do you get with not writing a custom binary sort?
What's that?
Although, if the interesting problem is not writing a custom binary sort, although writing one with the kind of soft selection where you're not likely to find the exact value, that is very interesting.
Yeah.
But if writing this is not the interesting part of the problem, then swap to go.
Yeah, and actually, I was wrong about this being because of exactly that. The interesting piece of this, we'd have to write a custom binary search either way. That's probably why it's worded the way that it is, because you can't just use last index of, because you're unlikely to encounter the reference value. And you could still, and you'd have to iterate up to 1,000 times before by random chance you're going to hit the reference value. So
where those are implemented, there's no soft search, no find nearest. It will either find exactly or return a -1 or a fail at some point.
Yeah, it seems that there should be a return nearest, but yeah, that's what we're writing is a binary search return nearest. Okay, I'm going to start from the beginning, kind of ignoring what I've written so far, just kind of thinking through the problem again from the beginning. So we're going to get a value that we're checking against. We're trying to find something less than or equal to that. I'm going to pick an arbitrary midpoint, which is M. My left boundary is going to start at 0. My right boundary, because I'm using indices, real indices. So then my right value is going to be 1 less than. Oh, you know what? I probably need to see. Hold on. No rush. Hold on. Oops. I'm going to tell them we couldn't get a reservation, so just come here.
We did a party on stream with even more people trying to solve this one.
All right. What was that?
You're having a dinner party on stream with even more people trying to solve this problem.
Oh yeah, that'll be great. Okay, so this is just for debugging, this count. But the leftmost we can possibly go is 0. The rightmost we can possibly go is inputs.length minus 1. So I'm 100% certain that left and right are correct. I think that M is correct because I think that we want to, on an odd number, I think we want to tend towards 0 because we can always go to 0, but we can't go past the index. So if we only had, let's see here, if we had, oh, this does present a problem doing it this way. Let's say that our input length is 0 and we do our input length minus 1, then we would get negative 1 divided by 2, we would get negative 0.5. If we floor that, that would give us negative 1. So this has a bug in it, but let me see if how would we fix that problem? Because I don't know how we fix that problem. I think that
JavaScript have just a move closer to 0 rather than a floor? Or round closest to 0?
that is, floor is round. Oh, no. No, floor is usually round closest to 0, but not with negative numbers. So if we take our, okay, so let's say that we have 2. Our inputs.length is going to be 0 or greater. So if it's 0, then this works because we end up with 0. If it's 1, this works. We end up with 0. If it's 2, this works because we end up with 1. So that just means that we start from the right. We start a little bit to the right. Starts just a little to the right. That's fine. Okay, so now this is workable. I think that that's as good as we can get because we either have to choose to be a little to the left or a little to the right. And we're just saying that we're going to start a little to the right. And that's fine because it's just a trade-off there. Okay, so we get here. For this test case, if the count is greater than 10, then we blew it. So this is just debug code here. All right, now we're saying we're going to get the value from I, which may be a little bit to the right. And then if I is greater than the reference, then we have definitely hit the rightmost value. So in the case where I is the rightmost value, namely when the length is 2, then the index 1 is the second element. Then we say that I cannot go any further than this, but we want to move it to the right. Oh, I think I might have missed having, no, we shouldn't have to have, I think this is wrong. So let's say that I is equal to 1, so right is equal to 1, but right was already equal to 1 because there was only 2 in the array in the first place. If it's greater, then we're trying to move it to the right bound, but I may already be at the right bound. That's fine. Okay, so then we want to take the left bound and So the left bound is 0 plus I minus 0 divided by 2. I think this is right. I'm not 100% sure that it's right for every edge case, but I think this is right. Are we guaranteeing that I will move to the left or break out of this? That I will move to the left if it can. All right. Guarantee that I will move left if it can. That's what we want to guarantee. So can we guarantee that in all cases, this will cause I to move to the left if it can? It causes the boundary to move to the left if it can. Technically, we could go with the right is I minus 1. I think that should work, but I'm going to leave that commented out for right now. Because we know that it's not I, so our boundary on the right is actually I minus 1. But I'll leave that commented out for now, because this should still work. So left, okay, 2 minus 0 divided by 2 is going to be 1. 0 plus that is 1. So if I was 2, then I will move to the left. And if I was 0, that would mean it can't move to the left. So left is 0, I is 0. 0 minus 0, 0, 0, 0, 0, 0, 0, 0. Break. I is as leftmost as it can be. Got it. Okay, now move to the right. If it's less than or equal to the reference. I think there's another condition here that I wasn't thinking about in both of these cases. What if I at position 0 is greater than reference? So let's say that the very first number is greater than the reference. Then, no, because then this will still catch it. Because if it can't move anymore, then I will break. I'm not sure. So this one must be wrong. All right, let's console.log here. Move to the left. We'll console.log here, move to the right. All right, I definitely failed this interview, by the way, because you said you had an hour and 15 for the whole thing.
Yeah.
And that included another problem as well?
Mm-hmm.
Yeah, I hard failed. Okay, so V is less than or equal to ref. Then left is going to be equal to I. Okay, let me make sure that makes sense. If the value is less than or equal to, then our left boundary moves up to I. I can go to the right, but it can't go any more left. Yep, that makes sense. Okay. Maybe I've got this part wrong here. Maybe I should actually be working with the left at some part of this. Okay, so I, let's say I is 2, and we want I to move to the right. Then 2 plus, and the rightmost boundary, if I is at 2, then the rightmost boundary could be 2. So 2 minus 2, 0 divided by 2. So 2 would be 2 plus 0 would make, that would break. Okay. This is the, and I is less than. Yeah, I'm actually kind of confused. I know I've got an error here, but I actually don't see where it is. One thing that I want to do is I want to console.log our inputs out so that I can so I can visualize that. And then work through this problem that way. Boop. Okay, that's not what I expected. Inputs. Oh, whoops, I didn't actually log out the inputs. Okay, let's see. So here's our inputs sorted. If m is equal to 4, then that would be 0, 1, 2, 3, 4. So it should be the first value. It would seem like it would be 16. Our left value boundary. Yep, so we want to move to the left. And then we move to the left and the value becomes 6. This doesn't make any sense. How could the value stay 16? We moved to the left, but it didn't move to the left. So that's what we need to debug. Why did it move to the left and nothing changed? The right value should have changed, but it didn't. So how's that possible? Move to the left. Okay, let me look at this one more time. Move to the left is the first thing we do. How could the right value possibly not change? Because I here is 4, and then right here is 7. That doesn't seem possible. Move to the left. What am I doing wrong? What am I missing? I is equal to j. Oh, no, if I is equal to j, we break. That's fine. Move to the left. Right. I'm so confused right now. Move to the left, 4. How is this possible? Did I reassign a value that I... Right. Did I do let right somewhere that I shouldn't have? No, this is correct. Oh, this might be my mistake. Oh, that might have been a logical error in just me looking at things wrong. I think that may have been the correct result after all. No, that definitely wasn't. Let's try this. Okay, move to the left. Okay, so that did work. We went to the next value. Okay, that's where I got tripped up on myself. Was that this whole section completed correctly? I need to add another new line there so I can... Yeah. Oh. Inputs M. Okay, so this actually came out with the right value on the first one, I think, because less than or equal to 5, the count is 4. That's correct. But then when we get to 100, it should give us 1, 2, 3, 4, 5, 6. Instead, 7, 8. It gives us 9, which is wrong. So it didn't...
It's failing to stop. Stop its move to the right.
So value is undefined. So how could we get an index of 9? This is what we need to focus on right here. Is we went from an index of 4 to an index of 9, which is obviously wrong. The way that it would do that is it has to somehow come out with 5. That's going to be adding 5 to 4. So let's look at this right here. If we solve this, I think we've solved the problem. So at this juncture, I is equal to 4 and right is equal to 7. So 7 minus 4 is 3. Divided by 2 gives us 1.5. Floored gives us 1. 4 plus 1 would give us 5. So this should be 5. So sanity check. let's do left, right, I. And then we should get left, right, and J. Okay, left, right, and J. How is this possible? Left, right, and I. Left is correct. Right is correct. J is wrong. So my math is just wrong here. Help me figure this out. What did I do so incredibly wrong here? Right is 7. Minus 4 is 3. Oh, parentheses, order of operations. That was it. Did you see it?
After you shouted it out, but it doesn't count.
No, I was just making sure you actually saw it at all. Hey, what's up, Crow Wasp? Okay. So now let's see how we do. I think we're still getting wrong. It's still coming out wrong because it's getting to a point where I should not be able to go beyond the rightmost value. That should be impossible, especially if we're moving to the left. Okay, how... If the left is 5 and the right is 6, how could I ever be 8? That just doesn't make sense. So let's take a look at that one. Because it says move to the left. Here, this is funny though, because this is the value of I, right? The 6 is the value. So how does it go from being 6 to suddenly being 8? Where did that get added in? Okay. I think this is further down the pipe. All right, what have we got here for left and right? Left.
Can you update your console logs down there so they say right, left, I, and J, rather than just saying move to the right too?
Yes. Move R. Or can we just do boop like this and like this? And then let's do all caps. Yeah, let's update that. So
left could be still moving right at this point.
Oh, whoops. This one's still moving right, sorry. All right, we'll rename this one. Whoops. J 2. All right, where else is I modified? Do we modify I anywhere else? Outside of this, here it's modified. But yeah, that's a little confusing to me. I'm actually not, I don't know if I'm interested. Yeah, we do want to see what that is there. So I don't know. That's a little confusing. Let's try this out. Okay, so here we had the values of 5, 7, and 6, and we ended up with 5, 6, and 8. So that tells us that when it moves to the left, it increased in value, which should not be possible. It should only be able to decrease in value if it's moving to the left. So let's take a look at that one right there.
I didn't look carefully. Is it the same parenthesis order of operations issue?
Could be. All right, so this is moving to the, and indeed it is. Same thing. They'll get you every time, man. Okay, so now that we have the right values, let's see. So for 5, whoops, let me just.
I think you're looking for 4 and 6.
Okay, so we're in the right ballpark. What we're seeing then is that we probably just need to add 1 because we're putting out the indexes. Yeah.
Yeah.
So we just need to convert it from index to length. So that should do it. All right. Boom. So
Do you
give
want one
me
more test case?
give me your worst test case.
Well, I don't have the really bad ones unless you want the random number generator thing.
Yeah, that'd be great.
The 10 million entries.
Let's take the random number generator. I'm going to take this and I'm going to turn it into a function here. So let me make this a little smaller. Sorry for people watching online, but I'm going to take this function and we're going to call it count, sure. And we're going to take the reference and the inputs, and this will return read problem description. I don't even know how to describe in words what it is that we're actually returning here.
Where do you want this? In the Discord?
Sure. Yeah, let's throw it in
They're
Discord.
only small little test cases. I have. And then the random number generator.
Yeah, I guess with the random number generator, we don't know what the right answers are, huh?
No.
So let's do this. Var tests. I don't know why I'm switching between var and let, but whatever. So inputs are.
Sorry, those are the two. I wrote that terribly.
Outputs are this, and the other one is similar. 1, 2, 3, 2, 4.
Mm-hmm.
And then let's add our own test case that we created here. Yeah, I honestly don't know how people solve these things that are timed and that have confusing questions. And I mean, I guess you are supposed to practice beforehand. You're supposed to have done this 3 times that week. And then be able to basically rattle off what you've already written and just choose the right algorithm that you're already familiar with having written 3 times. Because if I had written this 3 times this week, it wouldn't be so hard. But I live in the real world where I have to solve real problems.
Yeah, you spent a huge amount of time remembering how to do a binary search, and I guess that people who are deep into this and maybe at my level, maybe at least a bit more, have a bit more science background, would be able to knock out a binary search because you're doing it, as you say, 2 or 3 times a week.
But nobody's doing that. You don't write binary searches. No one writes a binary search. Every algorithm that you've ever heard of, you will never write because it's already there. No matter which language you're picking. If I just did a Google search, I could have found essentially the same thing, and I'd need to tweak it just a little bit to make it less than or equal to rather than greater than, less than, and equal to. I would have just need to modify it a tiny bit, right? You're never going to write one of these algorithms by hand. I mean, never is a strong word, but it's a solved problem. It's been done. There's no utility in solving these. There's no unique business value. It's just not something that you do. You do it.
And together with one of my classmates, I think they're taking some pretty serious ego knocks from not being able to solve the problem. and trying to work out what is the value of this stuff, except to show that you know enough of what's going on behind the scenes that you can, for example, not to do the naive solution here and wind up taking
Well, and in some
70
cases,
seconds to do a simple task, but to know enough to, in a sensible amount of engineer time, put out a solution that's efficient enough to get the thing done.
also they're literally, and in some cases, and I just hate trick questions. Tell me what you're testing me on, and test me on something that is relevant to what I'll do. But in a lot of cases, they are trying to weed out people from a neurological standpoint. So they're trying to find people that will respond a certain way to a certain problem. Also for social reasons. So they don't want to deal with people that think too broadly. They want to find people that can think in a very narrow way and about just the math sometimes. They don't want you to be asking questions about the business use case or about how customers are going to use this. They want you to stay in your lane. All you're going to do is you're going to solve the problems that we give you, and you're not going to ask questions. And you're not, I mean, in some cases, that sounds absurd to me, but in some cases, it's more similar to the military. That's actually a feature for them.
It doesn't fit with the modern full stack, agile, cross-functional teams where everyone's involved in the different states of the business, trying to find good solutions to problems together. But I can also see that you don't really want your juniors asking dumb questions the whole time, or asking questions the whole time. What you need from them is do the basics, learn to be a productive engineer.
Okay, so wait, these were refs. Oops. So these were refs, and these were expected. What is it? 2 and 4, and then this is expected. Oh wait, no, expected was. And then this one was refs, and expected was it 4 and 6?
Yes.
Okay. Now here's a neat little trick that works in JavaScript is we can actually compare arrays. We can do test.expected.toString equals test.answer.toString. And as long as your arrays don't have commas in them, then this is correct. So if you're dealing with numbers, you can do this.
Node also has the assert module, and then where's it gone? Deep equal. It seems quite nice too.
All right, I've got to go, but let's see if my tests are correct, because I think the code's correct at this point. Can't believe all that time was refs.
It's 7:06. I don't know what you're thinking, but it's 7:06.
Yeah. I'll be out in just a second. So he's still not here, obviously.
Well, then should I just go and get dinner for myself and you go out?
No.
I'm not gonna torture the kids.
No, he should be here in just a second. Here.
Our house?
Yes.
No, he's not.
Yeah, because we're gonna go out. He's not coming here to come here. He's coming
the
here.
Still open.
Yeah, it's fine. It's fine. Yeah, I will. Yeah, he's gonna get here. Let me see. All right. Well, anyway, I gotta go. But, oh, oops. Sorting that sorted my inputs.
But that's fine. Do you care?
I guess not. But I guess I should have taken a slice to sort it. Anyway, what is this complaining about? I did something wrong here. Oh, this is supposed to be refs. That's what it was supposed to be. Outputs. And then where was outputs defined? Did I not define outputs? Let outputs equals this. Okay, well, I'm not going to bother with it right now. Oh, that's supposed to be expected. All right, this is it. And then no test dot. Oh, just answer. There we go. Pass. I see some passes. So I'm going to assume that that's good enough. Is there more than one pass? Pass? Oops. Yeah, there's multiple passes, so we're good. All right. Well, that's that. Thanks for having me do a little refresher.
Next stage.
Oh, no. But thanks for having me do a refresher on my binary search. That was embarrassing. But I still got it. Just takes me twice as long as it would take to pass an interview. Or 3 times as long. And plus, I'd be even more nervous in an actual interview. It is humbling, yes.
Thank you very much. Could you drop your solution into...
I will later. Or I guess I'll just cut this out right now. And, yeah.
We forgot.
So anybody that wants to see this solution, oh my goodness.
Watch this one.
We're not going to watch that, sweetie. But I'm coming. I'm dropping it into the counts faster thread under the general channel. Oh, it won't let me do it. I'm going to have to do it later. Sorry, I got to go. All right, everybody. Thumbs up if you got them. Sub and follow if you want to. I'll catch you later. Binary search trees. Hard to implement from scratch. I'm out. And bye to you, Duncan. Thanks for the exercise here.
Thank you for everything.
All right. Adios.